How should we see dark matter? Dark matter is one of the darkest mysteries in the world we know, or perhaps the world that we do not know yet. Not all visible matters in the universe, such as planets, stars, galaxies, and everything we have ever observed, is gravitational enough to make the universe exist the way it is now. That is, the mass of all matters in the universe is less than what it should be on paper for the physical equations to be correct. So there must be a matter out there that we cannot see. Dark matter. Imagine a galaxy in the shape of our galaxy that is invisible. There are stars, planets, and even beings in this galaxy that we cannot see. A universe that is made of dark matter. Although dark matter makes up more than 25% of the universe and ordinary matter makes up only 5% of the universe, we have not yet been able to see it directly. Why can't we see dark matter? In this world, if we are going to see something, light or radio waves or sound waves must hit it and come back so that we can recognize its existence. For example, radars see with radio waves, our eyes see with light, and ultrasound devices with sound waves. But dark matter does not react to any of these waves. That's why we call it dark matter. But whatever it is, it's still matter. So we should be able to see it in interaction and dealing with other materials, at least for a little bit. How to see dark matter? Finding the location of a gas pipe or a bicycle tube leak with the naked eye is not an easy task, but you can put the tube in water to see where the air bubble comes from. Experiments to see dark matter must be performed with extreme sensitivity. In a laboratory about 2 kilometers below the ground level, there is a floating spherical chamber put in 345,000 liters of ultra-pure water. This chamber contains 3,600 kilograms of liquid argon at minus 180 degrees. Scientists are constantly monitoring the chamber from the surface, looking for the slightest light in this darkness. Finding a trace of dark matter in this experiment is like hearing the sound of a needle fall into a crowded street. That is why such laboratories are built underground, in the mountains, or inside old and deep mines. The ultra-pure water around the chamber also acts as a filter to prevent radiation and particles that have reached that point. Now, if we are lucky and the dark matter particles somewhere in this chamber have the slightest interaction with ordinary matters, the accurate and sensitive sensors of this detector can find it. Like a spark, extra vibration, bubble, or any other effect, this detector is like our eye against dark matter and records information at all times. A large amount of data is collected over the months so that we can examine them to find traces of the presence of dark matter. Maybe one day we will be able to unveil this dark secret of the universe and get to know the world we live in for the better.